So hi everyone, this question is asked by one of my student. It says there is a sphere which is resting on a vertical wall here and horizontal floor, and there is a triangular wedge which is in contact with the sphere at this point. Now the wedge is moved this side with a velocity of 20 centimeter per second. So radius of the sphere is given 10 centimeter, and the height of this point from the ground or the floor is given 2 centimeter. We are supposed to find velocity of the sphere. Now first of all understand, because of this wall this sphere cannot go this side, so therefore the only velocity sphere can have will be up. As this wedge comes inside like this sphere will go up. Now here the basic idea is we have to use wedge constraint. Wedge constraint says as long as this contact stays, the velocity of the wedge and the velocity of the sphere along this normal line must be same. That is the wedge constraint. So to find the components of this velocity and this velocity along this normal line, we need to have some angles, but here angles are not given, so that's why this height was given as 2 centimeter to first find the angle. So this is radius which is given 10 centimeter, right? Then if I draw this line, this height is given 2 centimeter, so this must be 8 centimeter. This much part is 8 centimeter. The diagram doesn't look to the scale, but it's okay, right? So this is 8 centimeter and this is radius which is 10 centimeter. So if I say this angle is theta, I can write sine theta as opposite is 8, hypotenuse is 10, so this is 4 by 5. If sine theta is 4 by 5, cos theta will be what? 3 by 5. I will need cos theta, you will see now. Now this end, this wedge is moving this way, right? Shall I draw here itself? Okay, let me draw here. So this is the velocity of the wedge. Component of that velocity along this normal line we want, perpendicular to the surfaces in contact. So this is the surface in contact. Perpendicular to that we need to find the components of the velocities. So velocity of the wedge is this side. Component of that velocity will be here this way, isn't it? So that velocity will be VW cos theta, because this angle is theta. Similarly, velocity of the sphere is this side, up, right? So let me draw it here for clarity. So this is the sphere, this is your normal line, this point is 2 centimeter above the ground as they told. So this dot line is this, okay? And your sphere is going this way with velocity v. This angle will be what? If you see carefully, this angle I want, isn't it? This angle and this angle are same. Now this is theta, so this must be 90 minus theta, because this is 90. So opposite will be 90 minus theta. So component of this velocity here will be what? V cos 90 minus theta is sin theta. So thus this velocity component, which is V sin theta of the sphere, must be equal to component of velocity of this wedge along this normal, which is VW cos theta. So we want sin theta is 4 by 5, velocity of wedge is 20, cos theta is 3 by 5. So velocity of the sphere will be 4 and 20 will give 5, 5 3 is a 15 centimeter per second, right?